Now today we are going to start relation, function and graph. So in the relation, function and graph, first of all we have to understand about the ordered pair. Ordered pair. In ordered pair, so first of all, what do we understand the meaning of the pair? Pair means two. Pair means two if any two elements are kept in order. If any two elements are kept in order, then that is called ordered pair. In symbolically, it is written as like that, A, comma, B. So this is called ordered pair. Normally, as we did before, sets. In sets, there we used curly bracket or called braces. So there we write A, B, C like that. This is called the notice. This is the notification of sets. So in sets, we cannot repeat the element, but in ordered pair, we can repeat. Even we can write A and A. But in the sets, we cannot repeat the element, just like A, B, C. So if in a sets, we cannot write A and A. So in a sets, we can differentiate like that. So this is called ordered pair and this is the form of sets. But this way we cannot write the sets in this form. So in ordered pair, we understand, just we have to know that ordered pair, how to write ordered pair. So ordered pair, so just I explained before, we can write 1, 2. This is called ordered pair. And how two ordered pair are get related, that we have to understand. Suppose if I will write 1, 2 and 1, 2, are that ordered pair are equal or not? Yes, they are equal because their first component and their first component are equal. Their second component and the second components are equal. That is why their ordered pairs are equal. If I will write in the place of 1, 2 and 2, 1, are they equal or not? So these ordered pair are not equal because we can see the first component and the first component are different. Second component and second component is also different. That is why these ordered pair are not equal. So, but you may confuse in the case of the sets. In a sets, you can write the elements in different order. So just like that, if I will write 1, 2 and if I will write 2, 1, both are the same set and they are equal. So that is the difference in this writing in sets or in the form of ordered pair. In ordered pair, they are different, but in the sets, they are equal. So to say ordered pairs are equal, their corresponding components should be equal. Corresponding component haru equal huनुपर्छ. Second component, second should be equal, but they are not equal, so they are not equal to. In this case, the first component correspond to the first components are equal. Second component and second component are also equal. That is why we can say that both ordered pairs are equal. So now we can understand ordered pair and how we can relate with the ordered pair. Now let's take some example of ordered pair and how to solve a problem on the basis of ordered pair if you have given. Suppose I will take one example, x plus y comma 3 is equal to 1 x minus y. If these two, they are given like that. And question is, you have to find x and y. Sorry, you have to find x and y. So now you have to find x and y, and this is the question. So how can we do? Just I explained before, if two ordered pair are equal, then their corresponding components should be equal. So, and the second component, corresponding second components are also equal. So here is x plus y, but here is 1. But the ordered pair are equal. The question says two ordered pairs are equal. If two ordered pairs are equal, then their corresponding components should be equal. Here is x plus y, here is 1. So you can write x plus y is equal to 1. You can say this is an equation, so you can write this is equation 1. This is 3, x minus y. So you can say x minus y is equal to 3. This is x minus y is equal to 3. This is an equation 2. This is an equation 2. Now let's see what happened here. So this is the two simultaneous equations here. Two simultaneous equation. We can solve these two simultaneous equation in different way. One is the graphical way, elimination, substitution, any method you can apply. But I like to simplify this by elimination. I feel easy to do by elimination better than the substitution. So how can we eliminate? So you know better how to do the elimination method. If here we can see the coefficient of y is same, their sign is different. If their sign is different, so we can add them. If we add these two equations, if you add these two equations, these get cancelled. X plus x becomes 2x is equal to 4. So then x is equal to, divide both sides by 2, becomes 2. Is that x value I have? And now, how to find y? So now, we have to substitute now the value of x equal to 2 in any one equation, as you like. So if I will put the equation value of x is equal to 2, now put x is equal to 2 in equation 1. So in equation 1, in the place of x2, I will put here 2 plus y is equal to 1. So what is the value of y? 1 minus 2 becomes minus 1. So you have to find x and y. So you get, therefore, we get what? X is equal to 2 and y is equal to minus 1. This is our solution. So this way we can find in ordered pair such type of question you have given to find the value of x and y. Now, after ordered pair, we have to understand Cartesian product. Cartesian product. How we can define Cartesian product? Let A and B be two sets. Let A and B be two sets. Then the relation of every element, then relation of each and every element of A, relation of each and every element of A with each and every element of B. The relation of each and every element with each and every element of B is called Cartesian product. Or another way also we can define Cartesian product is the set of let A and B be two sets, then Cartesian product is defined as the set of order pair Cartesian is defined as the set of ordered pair AB such that A belongs to A and B belongs to B. Okay, so notation of Cartesian product is written as, if A and B are two sets, then it is denoted as A cross B. It is read as A cross B. This is a Cartesian notation of a Cartesian product is represented as A cross B. I will show you the relation by arrow diagram. Suppose A is A, B and C like that, and B is the set having element suppose 1, 2 and 3. Then Cartesian product we can show like that by arrow diagram. This is set A, this is set B. A has element A, B, C. B has element 1, 2, 3. How I define Cartesian product? I said every element of A has a relation with each and every element with B. Is called Cartesian product. So A is get related with the 1, A is get related with the 2, A is get related with the 3, B also related with the 1, B also related with the 2, B also related with the 3, C also related with 1, C is also related with 2, C is also related with 3. This is called Cartesian product. If we have to write their Cartesian product in the set form, how can we write? So it is denoted as A cross B. A cross B is written as A is related with the 1, A is related with 2, A is related with 3, like that. B is related with 1, B is related with 2, B is related with 3, and C is related with 1, C with 2, C with 3. So this is the Cartesian product is called set of order pair. In which first component belongs to the set A, second component belongs to the set B. This way we can represent Cartesian product. So this is called representation of the Cartesian product. Okay, now after Cartesian product, we have to know about relations. Actually, relations is the subset of Cartesian product. In Cartesian product, what we define? Every element of A is related with each and every element of B. There is no any condition applied. But in the relation, element of A and element of B will be related, but there should be some condition applied. I will give some example. There is a set A. There is Ram, Lakshman, Krishna. Here is Sita, Rukmini, and Urmila. So there is a, I'm just going to find here the relation of husband and wife. So Ram is the husband of Sita, Lakshman is the husband of Urmila, Krishna is the husband of Rukmini. So this is a relation. But if we have to find Cartesian product, then Cartesian product, what Cartesian product will do? Cartesian product says Ram will get related with Sita as well as this, as well as this. So this is a Cartesian product. So, but in the relation, it is get defined. It get defined, well defined. Only Ram gets related with the Sita. Lakshman gets related with the Urmila. Krishna with the Rukmini. So this is called relation. So in the relation, there is a, we can find, so A and B is, it is related as, you can write as a notation X related. If you are writing related, that is called script R. So script R also we can write by different way like that, or we can write like that, or we can write like that. So better to write this way also. So here is X is related to Y. So X is relation with X belongs to A, Y belongs to B. So here is, you can write like that. First write in the set builder form X, Y such that X belongs to, or you can say X is husband of Y and X belongs to A and Y belongs to B. This is called in the set builder form. If you have to write in the listing form, so we can write like that. This is Ram, Sita, Lakshman, Urmila, and another Krishna, Rukmini. This is called the relation. So relation is the subset of Cartesian product. Okay. So now in a relation, so now we can define relation as. So relation from A to B is a subset of, we can define like that. Let A and B are two sets. Let A and B are two sets. Then X script R related to Y. X is related to Y. X, Y sanga related sa. Let A and B are two sets, then X related to Y is a subset of Cartesian product. Cartesian product A cross B, where X belongs to A and Y belongs to B, and X and Y are well defined relation. X and Y are well defined relations. So let A and B are two sets, then X is related to Y is a subset of A cross B, where X belongs to A and Y should belongs to B, and X and Y are well defined relations. So there should be, just like before I explained, So husband and wife relation. So that is a well-defined relations are there. So this way we can define relations. Now in a relation, now we have to understand in the relation there is a in the different form we can represent their relations, in the tabular form, in the graphical form. So for that I will take another example to show you in the tabular form and graphical form. Let's take one example. Suppose I will take A as 1, 2, 3 and B as 1, 4 and 9. So the relation is, so you have to find the relation and you have given like that, X script R related to Y is written like that, XY such that Y is equal to X square. This is the relation. Now this is the relation that we have to find the relation from A to B, where X should be belongs to A and Y belongs to B. So now we have to represent this, how to relate that one. If I will take X as 1, so what should be the value of Y? Just think about that. If X is 1, so what will be the value of Y? So how to do? Let's check. Just this is the value, this is in the place of X, this is in the place of X. X is 1, the relation is that. So if you replace यो 1 लाई X मा राख्ने, 1 राख्ने यहाँ, तो 1 को स्क्वायर कति हुन्छ? 1 नै हुन्छ. So Y will be 1. So you can write 1. Now there is, I will take 2 now. Okay, the value of X is 2. Value of X is 2. Now think, what will be the value of Y? So what will do? You will put the value of 2 here. If you put 2 here, then 2 square becomes 4. So Y will be 4. This way we can find the relation. Another, what is another element? 3. 3. So if you will put 3 here, then what will result? Yes, I know. You know that. That becomes 9. So this is the relation. That we can represent this relation in tabular form as well as in graphical form. So first of all, I will show you the tabular form. How to write in the tabular form? You have to make a table. You can write here X and Y. What is the first component of X? Is 1. What is the relation? With 1. So write 1 here. There is 2. What is the relation? 4. So 4. Now 3. Get replaced with a 9. So this is called a tabular form. Now graphical form. Graphical form. This is called y-axis. This is called x-axis. So we have to plot this point. So there is, I will write, there is 9. So there is not sufficient space here. So I will write little bit here, little bit down. Okay. So there is 1, 2, 3. There is 1, 2, 3, 4, 5, 6, 7, 8, 9. We need only that much. X. If I will plot 1, x coordinate is 1. So what will be the y coordinate? 1. So 1 point is here. Another is 2. So what is another value? 4. 1, 2, 3, 4. Let's see here. This is 1, this is 2, 3, 4. I will write 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is 2 and 4. 4 is here. So here you can plot. Now 3 and 9. Here is 3, 1, 2, and 3. 3, 9. 9 is here. So all 3 points we can see in a diagram. So this is the relation between x and y. So 1 get related with 1, 2 get related with 4, 3 get related with the 9. So this way, in the tabular form and the graphical form, we can represent the relation from A to B. Okay, now in a relation, now we have to understand the domain and range of a relation. So this term we have to understand, that we have to use many times in a function. So before starting function, so in the relation we have to understand the meaning of domain and range. What is the domain and range? So domain and range. Domain and range of a relation. So first of all, the same example I will take first. From there I will show you A, this is 1, 2 and 3, and B there is 1, 4 and 9. So relation x is related with the y is written as xy, such that y is equal to x square. This type of relation I took before. पहिले यही example लिया थे, त्यहीबाट अब डोमेन र रेन्ज पता लगाउँछ हामीले relation को डोमेन र रेन्ज. So how can we write this? We know that now. 1, 1, another 2, 4, and then 3, 9. Okay. So what is called domain here? What is called range? In a relation is a set of ordered pair. So all the set of first element of the ordered pair. The set of first element of the ordered pair is called domain of that relation. So we can define like that. Domain of a relation is defined as the set of first element of a relation of, you can say the set of first element of ordered pair of a relation, the set of first element of ordered pair of a given relation is called domain of that relation. Domain of that relation. So how can we write the domain? So domain of the relation is domain, you can write in the big D, domain is equal to, how can I write? What is the first element? 1 set of, so you have to just collect it. So 1, 2 and 3. This is the domain. Now what is range? So same way we can define range. The range is defined as the set of, similarly, how can we define? The set of second element. The set of second element. The set of second element of ordered pair. Ordered pair of a given relation. of a given relation is called, you can write, is called range. It's called range of a relation. It's called range of a relation. So now how can you write the range? So range is, just collect from there. That is the second element. What will be the second element? You can see before there is 1, 3 and 9. These are the second element of the order pair. So that is the set of range. So range is the second component of order pair. Domain is the first component of order pair. This way we can find domain and range of function. So we can take one example more to find the relation as well as domain and range. So I will take one example here. So suppose you have given a is equal to 1, 2, 3 and b is 2, 3 and 4, and we have to define relation as x is related to y is defined as xy such that you consider related sata. This is related as like that, x is less than y, where x belongs to a and y belongs to b. Now we have to find the relation. This is the question and you have to find the relation. So now x is related to y. How can you write the relation? Okay. We have to take the first component always smaller than the second component. The first component from where we have to take? The first component should be taken from a. पहिलो component a बाट आउनु पर्यो. So what is the first component? Suppose I will take 1. Okay, so I will take 1. With the 1, may I take 2? Yes, I can, because x is less than y. So first component should be smaller than y. पहिलो component, second component भन्दा सानो हुनु पर्यो. 1, 2. Yes, fine, we can take. Now, with the 1, yeah, 3, with the 1, 4, obviously. Okay. Now, may I take? With the 1, with each and every one we get related there. But can 2 related with the 2? Can 2 related with the 2? No, because x is smaller than y. This should be smaller than that. This is not small, this is equal. So we can't take this. We can take the value bigger than 2. Is any value bigger than 2? Yes. There is 3. There is 4. Okay. With the 2, we find all the relations. With the 3, what we can take? Can we take 3 with the 3? No. So we can take 3 and 4. Is there anyone? No. So up to there, we can find the relation. So this is the relation. Now we have to find what is the domain of that relation. What is the domain of that relation? What is the domain? First component. First components are the domain. But domain is written in the form of sets. You can see here is 1, here is 1. These all are domain. But what I said before, in a set, elements can be repeated or not? No, elements will not be repeated. So 1, if once you write 1 is the domain, there is also, so we cannot write the next time also 1. So फेरि 1 लेख्न पाउँदैन. एकचोटी मात्र लेख्यो. एकचोटी लेख्यो पुगिहाल्यो. This is the domain 1. Another domain 2. Because next time also 2 is there. But in a set, we cannot repeat the element. So 2 cannot be repeated there. So 1, 2 and 3 is the domain. And what is the range? Now we have to find range. Second component. What is the second component there? 2, 3 and 4. Everywhere 2, 3 and 4, 3, 4, 3, 4. So only when we can repeat only one. We cannot repeat the element. That is why there is the domain is 1, 2, 3 and the range is 2, 3 and 4. This way we can find the relation, domain and okay. Now take one question here. Let's see. One question is here. Let A is equal to 3, 4, 5, 6. The one set is given and the relation is defined as R is equal to xy such that xy belongs to A. Both x and y belongs to A. We have to take the value of x also from A, y also from same sets A. And what will be the relation from A, x and y? So sum of the x and y always should be 7. Then we have to express R as a set of order pairs and find the domain and range. So now let's see here their solution is. So now we have to find the relation. So R is equal to xy such that xy belongs to A and x plus y is equal to 7. So now let's see. Do you have any idea? Now take x from A first. Take any element from A. So first we can take 3. If I will take x is equal to 3, what will be the value of y? If I will take x is 3, what will be the value of y? Y is 4. Is it? 3 will go there, then we will get y is 4. Yeah. So y is 4. Now y is 4. Question says y must belongs to A. So the value of y we get 4. Is 4 lies in A or not? Yes. Here is. So we can write x plus y must be 7. Now we can take another element. Suppose I will take 4. First component we can take 4. If I will take x is 4, what will be the value of y? Y is 3. Is y 3 here? Yes. So we can take this. Don't confuse here. It's 3, 4 and 4, 3. In order pair, 3, 4 and 4, 3 are different. In a sets only there is 3, 4 and 4, 3 are the same thing. But in the order pair, they are different. So we can 3, 4 and 4, 3 are the different. So they are the relation. Now can I take another element or not? If I will take 5, the value of y will be 2. Is 2 anywhere there? No. So we can't take 5. Because 5 has no other relations. 5 has no any relations with the set element of A. 6, y is 1. Also not there. So only that much. So this type of relation we can find here. So after finding the relations in order pairs, we have to find the domain and range. So what is the domain of R? Domain of R is 3 and 4. What is the range of R? Range of R is 4 and 3. Same thing. So this way we can find domain and range. So what we understand here, domain and in the relations and how to find domain and the range. This way we can understand how to solve the problem on the basis of relations and finding domain and range. Now inverse relation. Inverse relation. So in a relation, as we did before, the relation, suppose we did before like that, A is 1, 2, 3, B is 1, 4, 9, the x is related to y is, we write here what we did before, 1 1 2 4 3 9. This is the relation. If we have to find their inverse, so their x component and y component, that will get switch. यो चाहिँ चेन्ज भइहाल्छ. यो यसको डोमेन, यसको रेन्ज भइहाल्छ, यसको रेन्ज, यसको डोमेन भइहाल्छ. So if we have to find the inverse relation, it is written like that. Inverse, like this is called R inverse. Inverse relation. Inverse relation, now we can write like that. XY, we can write Y. And then the relation is, how can we write inverse? Just switch it. So if 1 1, there is no difference, you can write 1 1. In 2 4, you can write 4 2. And now in 3 9, you can write 9 3. This is called inverse relation. So what is the difference in the relation and their inverse? The domain of relation is the range of inverse. Range of the domain is the range of the domain is the range of the relation is the domain of inverse. So here domain is 1 2 3. So here is the range is 1 2 3. So their domain and their range are the same. Their range is 1 4 9. Their domain is 1 4 9. So domain and the range are, so domain of relation is the range of inverse. Range of the relation is the domain of inverse. So this way we can understand inverse relation. Okay, now we have to start function. Function is the refined form of relation. Relation is the refined form of Cartesian product, and function is the refined form of relation. So we have to define function now. Especially we have to define function. How can we define function there? Actually, what is function? So function is an operator. Function is like a machine. Just like we can see in our village, our गाउँमा जसरी धान कुट्ने मेसिन हुन्छ, हामी धान राख्छौं, चामल आउँछ. सो जो मेसिनले जुन प्रोसेसिङ गर्यो, त्यहाँ काम गर्यो, त्यसलाई भन्यो फंक्सन गर्यो, त्यसलाई फंक्सन गर्यो, अपरेट गर्यो. सो मेसिन फंक्सनको काम गर्यो, धान त्यहाँ राखेको, त्यो चाहिँ इनपुट भयो, त्यहाँ राख्यो, त्यो इनपुट, आउटपुट के भयो त चामल पायो. So function is an operator in which we have to put something and we'll get output. In a language of computer, we can see in the keyboard, we press A, that is called input. We give input A, and on a monitor, we get display that later. That is the output. And the whole computer is work as the function. Whole computer, the computer is working as a function to display your later. So function is an operator. So in a function we can see, suppose there is any machine is there, we put their input and we'll get output from there. So we suppose we put input x, we'll get output fx. Here f is an operator. F is an operator. Here we put x, f make x as a fx. So fx is an output, x is an input, f is an operator. Now, but the function should be well defined. धान कुट्ने थियो भने धानै कुट्ने, मार्कर बनाउने छ भने मार्करै बनाउने. So that should be well defined. So how can we say that this is a function? This output came, so we get that output. So this output, by looking at output, we have to say that the function operate properly or not. Is it really function or not? This machine actually functioned or not? So for that we have to define function. So I will define function by, first of all, I will show you by this way. Here is, this is A, set A and set B. There is any element I will take, A, B, C. There is 1, 2, 3. So A get related with the 1, B get related with the 2, C get related with the 3. This is also another. I will make A, B, C, D. 1, 2, 3. A gets the 1, B is with the 2, C is with the 3, D is also with the 3. Someone operator are relate A with the 1, so something is working there. Some operator are there. There is A, B, C, 1, 2. A get rid of this also. So out of them, we have to define that which one is the function. So function is defined as, so I will write definition of function, then we have to identify which one are the function, which one is the not function. So function is defined as let A and B are two sets, then the relation from set A to set B is called function if, function defined like that. Now if each and every element of A, if each and every element of A must be uniquely related with the element of B. Now here maybe you have confusion. So how to understand uniquely related? Each and every must be uniquely related with the element of B. What is the meaning of unique? And also you have to be careful about this. Each and every and uniquely. These are the important things here. What I said? Function said only the case, the relation. Function is also relation. All the functions are relation, but all the relation are not function. So that is more refined form. Each and every element of A. No element should remain in A. कुनै पनि element यहाँ छुट्नु भएन. No any element of A should leave here. So each and every element must be uniquely means एउटा को एउटैसँग रिलेसन हुनु पर्यो. A को 1 सँग छ भने A को अरुसँग हुनु भएन. जसरी A को 1 सँग छ अरुसँग छैन. B को 2 सँग छ अरुसँग छैन, C को 3 सँग छ अरुसँग छैन, B को 2 सँग छ अरुसँग छैन, C को 3 सँग छ तर C को अरु कुनैसँग छैन. C does not have any relation with any other relations. D has a relation with 3, but D do not have any other relations. So D do not have any other relation with any other one. So yes, according to definition, it is every element is related but uniquely related, because each is related with uniquely. D has a relation with 3, but D do not have a relation with any other element. Each and every element has relation but unique. You can say, yes, this is a function. Their function. Their actually function is working. But here is their function is working or not? Is it function or not? So we can see A has relation with 1, it's okay. But A has also relation with the 2. So here is the contradiction. So here we can see that there is no relation. So there is this relation. Yes, this is a relation, but this is not a function. Yes, this is a relation, but we can't say this is a function. So 1, B is related with 2, but A is not uniquely related. Two things are not matching here. Every element should have a relation, so C do not have a relation here. So A, B and C do not have a relation, that is why this is not a, so the function is, this is not a function. These two are the function, but this is not a function.